Hello, hi. Wish you a happy 2015 and I hope you enjoy this course. The course is a Programming and Data Structures course offered by NPTEL and my name is Narayanaswamy and this is the first lecture of the first week of this course. The introduction to this course itself is interesting. You're going to see that this whole recording is made on my machine using 4 different pieces of software. The screen of my machine is being recorded by a software called Camtasia. It records my presentation, it records my face. Actually, it doesn't, it records uh, the output of another program which is called Photo Booth on my computer, which is displaying my face here. It's also recording audio, and after some time when I move to the slides, it's going to record the screen with the PowerPoint slides on it, and then I'm going to show you some programs. So I'm going to open a terminal and open an editor. It's going to record that also. So observe that this is one big program, the Camtasia for Mac, which is actually recording the screen of my machine, and this machine is running 4 different programs, and it all looks very complicated. And hopefully at the end of this course, by seeing this experience, you will be able to appreciate the challenges that a programmer faces. So periodically I will move between this application that displays my face on the screen, therefore you can see it, but most of the time you will be seeing either a set of slides, or you will be seeing a program, or you will be seeing the execution of a program, and I will be talking to you about it, which will definitely be recorded. Alright, so now I'm going to move to the slides, and I will be making such connectors in between, and that should not distract you too much. So I'm just going to go to my slides, and as you can see my whole screen and the applications which are there. My slides are made in PowerPoint, so I'm going to run PowerPoint. I'm going to go into the full screen mode and I'm going to play from start. Alright, so let's start. So the course, as I said before, is Programming and Data Structures. This is the first week and this is lecture 1, and we're going to keep this informal, so you will find that I will maybe stutter a little bit and so on, but technically the course is going to be complete and very interesting. In other words, I'm not going to edit the videos to sanitize it and clean it up so that everything is very clean and you don't hear ahs and oohs and so on. They are going to be there. They are going to be part of this course. Alright, so this is lecture 1, and the lecture 1 is going to last approximately 20 minutes. And we are going to have a short discussion on the outline of the course and also a review of C programming. So my name, as I said before, is Narayanaswamy and I teach at IIT Madras. Alright, so here is the outline of the course. The course is going to be the design of data structures. We are going to instantiate data structures. We are going to create and free space. And we are going to manage data structures, which means we are going to add keys into the data structures. We may delete keys from data structures. We may search an existing key. We may search a data structure for a key to respond with whether the key is present or not. And after describing data structures, we will use example programming exercises to implement these data structures. And all the programming will happen in the C programming language. Many of you have sent emails to me already asking about whether you can program in Java and C++. The answer to these questions is no. This is going to be a C programming course, and I expect a basic knowledge of C programming, the ability to write a program, the ability to compile the program, the ability to debug the program and run the program. And while data structures itself in most BTech, BE or computer science programs is often a course with a significant theoretical component, which means that there will be a lot of mathematical analysis. In this course, we will deliberately stay away from performing a mathematical analysis of any kind. So in other words, there will be minimal and almost non-existent asymptotic analysis. So if you're looking forward to learning asymptotics, order notation, O, omega, small omega, theta, and all that, this is not the course for you. This is a course where you will do a significant amount of programming by implementing appropriate data structures. That is the focus of this whole course. Alright, so let's go to the reference material for this course. We will use a combination of these references. As I said, these are reference material, these are not textbooks. So the book by Detail and Detail, See How to Program, is a good reference for software design methods, the C syntax, and it's also very rich in terms of programming exercises, starting from a beginner's level right up to an advanced programmer's level. Data Structures in C is another book. It's written by Ellis Horowitz and Sartaj Sahani. And this is definitely a reference material for you to understand the different data structures that we will study. How to Solve It by Computer by R.G. Dromey is a classic, and it talks about how to design programs. The last one by Niklaus Wirth, the inventor of the Pascal programming language, is titled Algorithms plus Data Structures equals Programs, and this is a reference material, and I encourage you to take a look at it. Alright, so the lecture plan, it's an approximately 8-week course. There are 3 lectures per week. Each week will be broken into approximately 6 20-minute modules. For example, today we will have 2 20-minute modules. The videos will be released on Monday, Wednesday, and Friday at about 6 a.m. on all these 3 days. And every week we will give one programming exercise. Typical submission deadline for the programming exercise will be 2 weeks from the date of release, and submission will typically be on a Wednesday morning again, latest, and the next assignment is also released almost at the same time on a Wednesday. There is a forum on the course website, right, at the NPTEL portal, and this is manned by me and my teaching assistants, and we will respond to your queries which are technical in nature, and we will decide which of the questions that you have posed that we should answer. We will, for example, not post code there. We encourage you not to post code on the forum, and there will also be 3 hangouts on air which are planned with the instructor, that is me. Alright, so what are the material that we're going to uncover? Right? I mean, I'm not going to cover material, so I'm going to uncover material, and I'm using this phrase which was coined by Professor Anant, the previous director of IIT Madras, who said that the role of a teacher is to uncover material to the student and not to cover portions. Alright, so the material that we're going to uncover in this course are, to start with, we will talk about recursion and the usage of pointers in the C programming language, and this is really a review of C, and it will be a quick review of C, and you should be willing to go out and experiment and learn C fast enough so that you can do well in this course. We will do examples of recursive programs, recursive functions. A classic example is the Towers of Hanoi problem, which we will definitely study. Then we will also study abstract data types, and abstract data types are abstract descriptions of data structures. Many of you have already had questions as to what are data structures. That's a very good question, and we will address that by formally defining what a data structure is. Okay? The formal definition of a data structure is captured using the concept of an abstract data type, and this is the definition. And as a C programmer, abstract data types are often specified in .h files, and you can also use your abstract data types by using the hash include primitive that comes with a C programming language. Then specific data structures that we will study are arrays and lists, and these are the basic data types, and we will solve different programming exercises using these basic data structures. For example, we will write programs to multiply polynomials. We will write programs to represent sparse matrices, that is, matrices where predominantly there are many zeros and very few number of ones. We will then implement algorithms for searching and ordered searching, for example, binary search. By ordered searching, I mean searching an ordered set. We will then look at other abstract data types which most of you may be familiar with or heard of. For example, we will study the two data types, stacks and queues. Remember, I'm not saying data structures, I'm calling stacks and queues as data types. And we will study the stack and queue data type, and we will use them in programming exercises like expression evaluation and non-recursive implementation of recursive functions. For example, we will write a program which is iterative in nature. It's not a recursive program, and it will solve the towers of Hanoi problem. It will maintain a stack, and you will see how stacks play a very important role in simulating function calls. We will then move on to nonlinear data structures, which are examples of which are trees. Then special kinds of trees are expression trees, and then we will study algorithms for tree traversal and the application of tree traversal in generating assembly code. We will then look at search trees, and for example, you might have heard of binary search trees, and we will look at methods for inserting keys into a binary search tree, deleting keys from a binary search tree, and efficient find key by maintaining the search tree in what is called a balanced fashion. Then we will look at fairly advanced nonlinear data structures which are used in operating systems, right, to maintain priority queues, right? And priority queues are maintained using data types called heaps, and we will see how heaps can be implemented on top of the basic data type arrays, and the analysis of heaps is often visualized as an analysis of some special properties on some underlying trees. All these details will follow, and you do not have to be put off if you don't understand many of these things. But this is essentially the syllabus of the course. The last item that we will talk about is what is called the dictionary data type. The dictionary data type is a very powerful data type in which you can actually ask not only questions about whether a word is present in the dictionary, but you can also ask for prefixes of words, suffixes of words, and even word completions. So that would really be the most advanced data structure that we will study and use in our programming exercises. So this is really the syllabus of the course, and these we expect to cover in approximately 8 weeks' time. So what does a typical lecture look like? A typical lecture looks like today's lecture. You saw me talking about the lecture itself, right? That would last for approximately a minute, and then we will go through about 15 to 20 minutes of a presentation of the lecture material of the day using PowerPoint slides. For example, in one lecture, I might describe one particular abstract data type. That is, it is the explicit specification of a data structure. And what would the abstract data type actually be? It would say what are the different types of data. For example, you may say that your data type has 5 integers, 5 characters, and apart from the abstract data type, we will also maintain or describe the access methods associated with this data structure. For example, we will look at methods which will add keys into the data type, which will add keys into the data structure, delete values from the data structure, and query the data structure for the presence or absence of a certain value. Now, the definitions of this method and the description of the data type would be written in the C programming language, and they would always be put inside a .h file. This is a programming practice. So not only do you learn data structures, but you also learn a bit of programming practice in this course. And then we will write what are called wrapper programs. These wrapper programs will instantiate objects of the newly created data type, and you will see what I mean by this. And these wrapper programs will be compiled and executed, and this is what a typical lecture will consist of. Then, after talking about the data structure by describing the data type and then looking at some programs which implement the methods associated with the data type, we will go on to the second part of the lecture and we will describe one programming exercise. And this programming exercise will be explained to you clearly by way of specific input-output relationships. After understanding the programming problem, we will design the program, and when we design the program, we will essentially make a choice of the appropriate algorithms and the appropriate data structure. Then we will move on to the implementation of the design program. What is an implementation? We will typically open a file, look at a C program, we will analyze the different statements in the program, we will essentially look at an implementation of the algorithm. Then we compile the C program, then we will test it, analyze it, and compare it, and the comparison will typically be a comparison between the usage of maybe one or two different data structures for one particular programming exercise. So this is essentially going to be our typical lecture, and now let us move on to a typical lecture and let us go and move to one particular program. And this is a warm-up exercise, and it also tells you what the flow of the lecture is going to look like. Okay. So now what are we going to do? We are going to look at a very simple program. The goal of the program is to sort, and I'm going to show you an implementation of a very popular algorithm called the insertion sort algorithm. Now what we do is we move to a C file which is viewed using an editor. Now sometimes you may not completely understand what I am doing on this screen because I am using the VI editor. You may use some other editor when you program on your machine. So focus only on the C program and do not focus on the commands that I type inside the editor. Those are not important at all for you to learn programming and data structures. Every editor that you use has its own features and you may choose your own editor. Now the most important thing for you to notice is that when I open this program, you will see that the program is very well documented. It is a programming practice that you must follow. You will see that there will be an initial part where I will have described what the program is supposed to do. I would have described what the input and output is. There will also be some small amount of information as to who wrote the program, and inside the body of the program there will be some small very informative comments as to the role of different statements. So let us go to our program, and I'm going to move away from this presentation. We will come back to this presentation in a short while again. Alright, so that was a short description about what a typical lecture is, what the material to be covered in the course is. Like I promised, we will now move to the C program. So we are moving into the second part of this first lecture in this first week. Alright, so this is my terminal window, and this is the command prompt. I am going to open this program. VI is my editor program, please do not worry about it, and the program that I have already created is called Week1 Lecture1.c. Alright, so this is the C program and this is my editor, and if you know your C program, you should not be confused or you should not have a question as to what the first sentence here in this program is, the hash include stdio.h. Now you can see that I have a long C comment from starting from this place onwards. This completely describes what the program does. For example, it says that the program is written by me, N.S. Narayanaswamy. It also says something about what the input of the program is. We will assume that the input is in two lines. The first line is a positive integer value not larger than 1,000. So this means that when your program runs, you will have to give an input on the first line, and this value should not be larger than 1,000. Of course, you can ask what happens if you give a value larger than 1,000. The behavior of the program is unpredictable. In the next line, the input consists of a space-separated sequence of the number of integers that you have said will be given. And at the end of this sequence of integers, you type a end of line character, otherwise which is called, you press the return key. Now the output of the program is described on this line. The output is the input sequence printed out in ascending order in a single line, and the consecutive elements are separated by exactly one space. And observe that I've written exactly in capital letters. You should keep in mind that when you submit your programming exercises, you will have to follow such important rules to ensure that the evaluation system does not get confused by the output of your program. Right? So this exactly one space is extremely important. This comment ends. Okay. So now we are into the C programming part of it. This sentence, this statement is a function prototype. And if you know your C programming, right, or even if you don't know, this is a new concept, it's a good programming practice to declare the functions by giving the name of the function, the return type, and the argument types at the beginning of the program. I repeat this, it's a good programming practice. Sometimes it's very necessary, but initially it's a good programming practice to follow this habit of declaring your functions. In this case, observe that the declaration consists of only the prototype of the function. The name of the function is insertion sort. There is no return value, that's why I've written void there. And there are two arguments to this function. One is a pointer to integer, that is int star. The other one is an integer argument. Note that there are no variable types here, there are no variable names here. This is the difference between a declaration and a function definition. We will see a function definition shortly. Now, a declaration is very important. It is very important for the compiler. In this example, it is not conceptually necessary, but it is very useful in many programs when you become an expert programmer, that the function definition may be in another file. Note, the function definition may be in another file as opposed to the function declaration, which is here. So here is a function definition and here is the function declaration. Alright, now let's go to the main function of your program. Right? Alright. So the main function of the program, it's called main. It returns an integer, and we will see how to use these return values very carefully as we go through this course. But really that is not the focus of the course. It is something that you must be interested in as a programmer. But we will definitely visit it, but not spend too much time on it. Alright, so since this is a simple program, it's a review of the C programming language. I have an integer which is called number of keys, and I have an integer array of 1000 which can contain 1000 values. It's called values. The array is called values, and I have an integer variable I which I use as an index. Now note that I read the first data item, which is an integer. So here I am reading in the number of keys that are going to be stored in the array. Here is a loop which then reads the values one after the other. Note the usage of ampersand and the values of I, and notice that this for loop reads starting from location 0, starting from the 0th element in the input to the element whose index is number of keys minus 1. That is a total of number of keys, number of input elements. And this is the standard for loop that you must be familiar with. And as you do this, I am sure some of you will ask questions like, what happens if the user gives data which is smaller than the number of keys? What if the number of values which are given in the input is more than the value of number of keys, and so on? That is a remark that I have put in saying that this is considered to be future work. And now we make a function call to the function insertion sort, sending it values. That is, observe that this is a pointer to the first element of the array, and we are also sending the number of keys which are the relevant values that need to be sorted in the array. Now, the way the program is designed is that when the execution returns from this function call, at this point the values array would be now sorted, and in this for loop we print the values one after the other with a space between the two of them. Finally, we terminate the printing by giving a carriage return or a new line, and the execution ends by returning a value 0. I hope that was clear. That was the execution of the main program. Now we are going to look at the design of the function called insertion sort. So the function is called insertion sort, and it does not return any value, and that is why you see the void here. Now observe that the data type of the first argument is a pointer to integer, and you will already recognize that the variable pointer to values contains the address of values of 0 whenever this function call is made. When control enters this function, ptr underscore to underscore values contains the address of values of 0. Further, the variable size, which is a local variable local to this function, contains the size of or the number of relevant elements in the values array that need to be sorted. Here are two local variables. From the C programming syntax, you will, I'm sure, not get confused by the reuse of the variable name I, because when the execution enters this function, the meaning of I, of this word, this variable name I, is completely local to this function. Then I have another variable called j, and I have a temporary variable which is used to exchange the values in two locations in the array. Okay, so what does the insertion sort algorithm look like? Observe that there is a first for loop. The role of this particular for loop, and let me just highlight this region, the role of this for loop, right, is written in this remark. In the ith iteration, the ith element is inserted into the correct place in the range 1 to I. That is, when the control enters the ith iteration, the goal is to take the ith element in the array. Right? What is the array called now? The array is called pointer to values. It's deliberately called pointer to values. As the control enters this loop in the ith iteration, the goal is to insert the ith element of pointer to values, the array called pointer to values, in the correct location inside the elements 1 to I. That is our goal. Fine. So let us imagine a particular iteration number I, and let us understand the next for loop. The role of this for loop is to insert the ith element into the correct place, and let us see how to do it. The way this is done is to move backwards from the I minus 1th element up to the 0th element. That is the role of the index j. The role of the index j is to run from the index I minus 1 in the array to the index 0, and in a sense it is running backwards. It starts from I minus 1 and it goes up to 0. And what does this do? It checks in each loop, it checks if the j plus 1th element, that is in the jth iteration, it checks if the next element, that is the j plus 1th element, is smaller than the jth element in the array. If it is indeed smaller than the jth element in the array, then these three lines are very famous lines which every programming student would recognize. This exchanges the values in the locations I plus j plus 1. These three statements exchanges the values in the location j plus 1 with the value in the location j. How does this happen? Temp stores a copy of the value in the location j plus 1. Then the value in the location j is copied into the value into the location j plus 1. Then the value in the location j is made to be the value which is stored in the temporary location. When are these three statements executed? They are executed when there is a wrong order between the j plus 1th element array and j plus 1th element in the array and the jth element in the array. In other words, when the j plus 1th element is smaller than the jth element in the array, the exchange is affected. Otherwise, right? In other words, if the j plus 1th element is at least as large as the jth element, then we observe that the ith element has found its correct place, and we break from this iteration using the C programming statement, which is break. Let us recall what break does. Break breaks from the enclosing loop, which is this for loop. That is, the control, after executing this break, exits from this for loop and comes to this particular location, which means it will move on to the next element of the array that we are sorting here. Eventually I will touch size, and then it will get increased to size plus 1, and then the control will exit from the loop. And as you can see, by just thinking about this a little bit, after every iteration a certain prefix of elements of the array are sorted. In other words, after the ith iteration, the first I elements, that is the elements indexed by 0 to I, are sorted. Let me make the small change so that you can notice this. I have written in the correct place in 1 to I, it's actually 0 to I. Right? Therefore, after the ith iteration, the first I plus 1 elements are sorted, and eventually the value of I will become equal to size, and eventually it will cross the value of size, at which time the control will exit and return from this function. You will also notice that I have missed a return statement. It doesn't matter, but again I missed it so that I can show you that it's a good programming practice to put in some of these comments. Put in the appropriate statements. Alright, so once control reaches here, it goes to the place where the function was called from, which in this programming exercise is here, and then we put in the remark saying that values, the array is now sorted. Some of you may wonder, how does values get sorted while the insertion sort was executed on this array? Now, this is the beauty of passing addresses, which is a very powerful feature of the C programming language. Observe that PTR of values points to the parent array, if I can use that phrase, values, which actually contains the values that you want to sort. And this is a very useful feature, but also a very dangerous feature. If you make some mistakes here in this part of the code, in some other programming exercise, for example, if you delete values, then the values might be completely lost. So it is very important for you to remember to use pointers very carefully when you pass them from one function to another function. Alright, so this was the whole program, and now I'm going to compile this program for you so that you can see it. Don't worry about the WQ. In the VI editor it means write and quit. Now I am back to the command prompt and I'm going to compile my C program. So let me compile this. CC is the C compiler. I'm going to compile the program that we just wrote, and I'm going to send the output to this executable, which is week1.1. The compilation is successfully completed, and let us look at the kind of mistakes that we can make while giving inputs. And these are the kind of mistakes that you are expected to program for when you start writing very sophisticated programs. So let us execute the program that we have just written. In other words, we have compiled it and created an executable. Let us execute this program. Now the executable is ready. Now I have deliberately designed the program so that there is no message to you, because when you submit your programming exercises, there will be no such interaction between your program and the program evaluation environment. For example, it is useless for you, or actually it is dangerous for you to give messages like, hello, please print your input. Such kind of messages are not to be given when you submit your programming exercises. Just the values need to be given. So let us give a value. Let me say 6. Remember that 6 stands for the total number of keys that we want to sort. Now the system waits for the 6 keys that need to be given. Let us give 6, 5, 4, 3, 2, 1, and you see the output is sorted in ascending order because of our insertion sort algorithm. Now let's run this on an input that consists of negative numbers, and you will see that that also works perfectly fine. -6, -9, 1, 0, 3, 4, and just for the fun of it, let me introduce 7, which is one more key than what we have said we will give. And as you can see, the last element is lost. Right? Even more interestingly, let us make the same mistake. Let us make it -9, -6, 0, 1, 3, 4, and -10. -10 is lost. Now, it is important for you to analyze why. It is not very hard, but it is important for you to analyze that. Now let us see what are all the mistakes that we can make when we give inputs. And these are the kind of mistakes that you must be careful to avoid by reading the programming assignment statement very carefully. Again, let's give 6 values. Let me give -9.0, 1.1, -2, 3, 4, 5. Yes, I finished giving 6. Now observe that the output is highly likely to be some very unpredictable output. And this is a problematic situation. So you must be very careful when you give inputs to such programs. Remember, the programming exercise was to sort a given set of integers and not numbers. So this is an extremely important thing. Similarly, let's make another input. Let's give lesser number of inputs than what was promised. So let us give 6. Let's give 2, 4, 1, 3, and 4, and 3, and more and more and more, and observe that the program is waiting for numeric inputs from you and it is skipping all the space. So now that's -7. Now the whole input has been given and interestingly it is sorted. So this also tells you something mysterious about scanf. We will not talk about it, but I encourage you to explore how scanf works. Now let us go to our program again and make some special kinds of errors just to understand and just to revisit the C programming language. For example, a standard mistake programmers make is when they scanf, they forget the ampersand. Now let us see what's going to happen by compiling our program. Now this is very important. Observe that the compiler has given only a warning. It doesn't say that there is a error. It only generates a warning, which means the compilation successfully went through. So let us run our program and see what happens. And you're going to see that missing the ampersand has a fatal consequence at execution. As you can see, the execution terminated with a segmentation fault, and this is a fatal execution because the execution of the program was terminated, and you have a error that we are not going to talk about, but again you can go out and study what segmentation fault actually means. So let's go back and correct that error. The role of the ampersand is very crucial. And you must understand what the ampersand actually means, and it is not very hard. A few practice sessions with scanf will clarify the role of the ampersand. Observe here that I have said ampersand values of I, right? So observe that in English you would read it as the address of values of I. And that would get rid of much of your confusion. Alright, so I hope you've looked at the program carefully and looked at the execution and the different kinds of errors that we can make. Also, if you notice, we have passed the values, right? That is the address of values of 0 by passing a pointer to the function which does the insertion sort. Right? So therefore, this is a simple program, but for those of you who are using pointers for the first time, so you should get brave and go out and study pointers and use them, because it is not possible to maintain data structures without being comfortable with manipulating pointers in the C programming language. Alright, so that finishes in some sense our hands-on session, and let us get back to our slides. Okay, so I hope you enjoyed this session of looking at a program which was written by me, and you can write similar programs. I encourage you to write similar programs with every programming exercise, every data structure, every algorithm that you study. Write a small piece of code, make it work on toy inputs, and you become a stronger programmer. My motivation for showing you that is to show you that programming is not hard. It's an exercise to be logical, to follow a rigid syntax, to not forget details like the role of the ampersand and so on and so forth, to pass pointers carefully, to modularize your code, that is, write appropriate functions to make your program very readable, put in appropriate comments. Programming is like poetry. It's a very enjoyable task. So let's get back to the slides to review what more needs to be done before we end today's lecture. Alright, so this was the latest program slide where we went to the terminal, we opened our program and then made changes to it, studied the code, compiled it and executed it and understood its execution. Very importantly, what are the different kinds of errors we made? We should not miss the ampersand in the scanf, and very importantly, you must apply it to the correct data item. And there was another very important thing. This was an error that we did not create. We will definitely create it after going through these slides. Okay? And when you use scanf, it is very important for you, along with the format specifier, not to add additional characters. We will go back and see what I mean by this. I hope you also noted the value that was passed. I hope you also noted the value that was passed to insertion sort. It was an address. In other words, the value that is in red here, the memory location value, consists of the address of value of 0. And did you also notice that I accessed pointer to value of I? That is, I accessed the ith element in the array whose name is pointer to value. I hope you noticed it. I'm not going to tell you the reason for these things. You're supposed to become familiar with these. Another very important thing that we did is that we also were worried about the efficiency. That is why we added the break statement. In the break statement, remember that we avoided unnecessary comparisons. Right? Now, here is a small exercise. Come up with an example where many comparisons would be made if we did not put the break. Observe that the break is not important for the correctness of the program. Even without the break statement there, the program would have been correct. Right? Now, it is very important for you to put the break statement at the correct place. It's very important for you to put the break statement at the correct place. You must put it in the loop that you want to break out of. Also, did you notice the input types when we tested the program? Only integers. And you also notice that the output is highly unpredictable when the input types are not respected. What are the outputs? Those are not very important. Right? We should not really care about what the output is when the input is wrong. Right? Okay, so what is the additional reading that you must do before you get to the next lecture? Review your C programming from your favorite book. In particular, please become familiar with pointers, become familiar with the syntax of scanf, how to pass values to pointers, what are return types, and so on and so forth. Write as many simple programs as you can and come back to the next lecture. We will study pointers, we will study structures, we will make function calls, and we will also return values from functions. And that video will be released day after tomorrow morning. Thank you very much for your attention and enjoy yourself. I'm going to stop the lecture now.